Now that we've spent most of our unit talking about our different parallelograms, we're going to talk about a couple special types of quadrilaterals that are not parallelograms. Both of these quadrilaterals should have been ones that you've heard of before, but we're going to talk a little bit more about their characteristics and a few theorems related to them. So first off, a trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. We alluded to this earlier in the unit when we were talking about parallelograms that of course have two pairs of parallel sides, but a trapezoid has one pair of parallel sides. The parallel sides are called the bases of the trapezoid. And then the non-parallel sides are called the legs. So you have bases and legs of a trapezoid, kind of like you have bases and legs of like an isosceles triangle. So we have some of that same terminology. So notice the drawing on the right here does have the two bases, are the parallel sides, and notice the parallel markings, and then the legs are the other non-parallel sides. We also have something called base angles, and again, that term is used with isosceles triangles. So there's a lot of similarities here in some of that terminology. So you always have a pair of base angles though. So you would have like one pair here and here, and actually I'm not even going to mark them as congruent, but because they may or may not be congruent, but you have one pair of base angles there, so D and C would be a pair of base angles, and then angle A and angle B would be a pair of base angles. So the angle that we refer to as a base angle is usually in a pair, and it's always between the leg and the base, the leg and the base. Okay, so that's what's stated down below here in trapezoid ABCD. A and B are one pair of base angles, and C and D are another pair of base angles. Now, if the legs of the trapezoid are congruent, then it's a special type of trapezoid called an isosceles trapezoid. Oops, isosceles. So I-S-O-S-C-E-L-E-S. That's always a tricky one to spell. So isosceles trapezoid. So if those legs are congruent, just like if they would be congruent in a triangle, we'd have an isosceles triangle. If the legs are congruent in a trapezoid, then we have an isosceles trapezoid. So we have a few theorems, a few characteristics of trapezoids besides their definition characteristics. So if a trapezoid has isosceles, then not only are its two legs congruent, but also each pair of base angles are congruent. So you'll notice that angle G and H are a pair of base angles, they're congruent, and F and J are another pair of base angles, they are congruent. And it's a different pair of congruent angles than the ones that are the G and the H angles. So that's always going to be true. And again, once again, we are talking about a characteristic that is just like an isosceles triangle, which also had congruent base angles. 6.22 says if a trapezoid has one pair of angles that are congruent, then it has to be an isosceles trapezoid. So this is kind of like the converse of 6.21. So if we have base angles that are congruent in a trapezoid, then it has to be an isosceles trapezoid. So if we have one pair here, that would also mean that this pair down here would have to be congruent as well, because if it's an isosceles trapezoid, then both pairs of base angles would be congruent to each other. Okay? So if it's a trapezoid with one pair, then both pairs of base angles are congruent. 6.23 says, a trapezoid is isosceles if and only if its diagonals are congruent. So notice this phrase right here is our biconditional statement, if and only if. So this also works in forwards and reverse then. So a trapezoid is isosceles if and only if its diagonals are congruent. So if we see this trapezoid and we know it's an isosceles trapezoid, then we know that QS and RT are congruent to each other, those two diagonals. Conversely, if we know we have a trapezoid and we have two diagonals that are congruent to each other, then the trapezoid has to be isosceles. So in other words, then we know RS and QT are congruent. So it's kind of a test of isosceles trapezoid is those diagonals being congruent. Okay, so let's apply a couple of these theorems. So starting off with example 1. So it says the speaker shown is an isosceles trapezoid if the measure of angle FJH is 85 degrees and the distance from F to L is 8 inches and J to G is 19 inches. Find each measure. So let's write that information in. So F to J to H, we're talking about this angle right here. So FJH, so that is 85 degrees. We also know that FL, so L is a little bit hard to see here, but here is L, and maybe I'll even use a different color. I don't know what would be easiest here. Let's use red. So there is L right there. So F to L, that distance right there, is 8 inches. And then JG, so J to G, so this entire distance from J to G right here is 19 inches. Okay, so we know it's an isosceles trapezoid, right? So we know something about the diagonals, we know something about the base angles. Let's go ahead and answer the question. So first question is, what is FGH? So F to G to H is this over here. So this angle right here. All right, so let's see. We know that in an isosceles trapezoid, the base angles are congruent. So if we know this is 85, then we also know this other base angle over here is 85 degrees. Remember, we also know that we have a pair of parallel sides, opposite parallel sides, because that's the definition of a trapezoid. If those sides are parallel to each other, then we know the consecutive angles between those two bases would have to be same side interior angles and therefore supplementary. So this angle up here has to be supplementary to the one down here. So FGH is going to be equal to 180 minus 85 degrees, which would leave us with 95 degrees. So we use some of those same parallel line properties, just like we did earlier this unit with our parallelograms, but since a trapezoid has parallel sides, one pair of parallel sides, then we can also use that parallel line property, same side interior angles are supplementary. All right, our last question on this page is what is the distance from L to H? So remember, L is this point where the diagonals meet, and we also are given that this is 8, and we don't know L to H, but we do know the other diagonal is 19, right? So in a trapezoid, the diagonals are congruent. So in other words, J to G has to be the same as F to H. Well, if we know one is 19, the other one has to be 19. And if we know part of it is 8, then that leaves us with 19 minus 8, which would give us 11 inches. So L to H right here would have to be 11. So 8 plus 11 is equal to that 19.